Greetings, math fans. All right, so this is day 7, which is actually worksheet 6, okay? And basically what we're going to do is we're going to add and subtract radicals. Okay, so this is add, subtract radicals. Okay, it's actually pretty easy. Basically, in order to add and subtract radicals, let me just give you an example. 2 root 7 plus 3 root 7. Okay, in order to add and subtract radicals, these numbers underneath the radical, they got to be the same. All right? If they're not the same, you can't add them together. And this is the square root, right? The square root, these numbers have to be the same too. So in other words, one can't be the cube root, one can't be the square root. They have to be both square roots, both cube roots, both fourth roots. So that also is the same. So let's kind of think logically. If you've got 2 root 7s in your pocket and I hand you 3 more root 7s, what do you got in your pocket? You've got 5 of those, don't you? You have 5 root 7s, and that's the answer to this problem. So it's like really easy. It's like when we add x's together. If I said, 3x plus, or let's say 2x plus 3x, if you have 2 x's, I give you 3 more x's. How many x's do you have? You have 5 x's. So it's kind of the same idea, except it's a radical. Okay? So just make sure that number's the same underneath there and the same root, like both square root or both cube root, whatever, and then you can add them together. It's actually pretty easy. All right, so let's just do quickly a couple of these guys here. If I said 8 cube root of 10 plus 7 cube root of 10, okay, what do you get? Well, they're the same number under the radicals. So they're both cube roots. So 8 of those plus 7 of those is 15 of those. And that's your answer. Okay? Super easy. Okay, that's really, really easy. Same thing with just subtraction is the same thing, right? If I said 7 times the fourth root of 5 minus 12 times the fourth root of 5, basically, as long as you recognize that they're both fourth roots of 5, you can subtract. So I can say, 7 minus 12. That's really what I'm doing. Put that in your calculator. Oh, it's negative 5. Okay, so the answer is negative 5 times the fourth root of 5. All right, so sometimes maybe you'll need a little help, not really, but just doing that. I mean, that's just the basic math, right? 7 minus 12. Okay? So pretty easy. Now, the only time it is not quite so friendly is when numbers aren't the same. Okay, now, yeah, I know you're saying, well, listen, Mr. Garbage, you said you can't add and subtract these. Well, if I gave you something like 2 times the cube root of 8 minus 7 root 2. Right, you right away would say, well, you can't add and subtract these because they're not the same number. So the deal is you've got to simplify that radical. Okay, so you got to look for that square root of 8. You got to simplify it, and I've told you this many times. So let's just review it. Remember, you're starting to divide it by 8. You get your calculator. You say 8 divided by 2 is 4. Then you divide that 4 by 2. Remember, this is what I told you to write on the top of your paper. 2, 3, 5, and 7. Those are the numbers you want to write on the top of your paper. So that's the numbers you're going to divide. So I have 2, and then that 4 becomes 2 and 2. So that's broken up, minus 7 root 2. So remember, guys, all you need is a pair of something, and that comes out. So when that comes out, you just get 2, and then the 2 comes out. That's my 2 I just took out. And what do I have left over? I have that 2 there, minus 7 root 2. Okay, so this becomes 4 root 2, then minus 7 root 2. 4 root 2 minus 7 root 2 is negative 3 root 2. And we're done with the problem. Okay, so you are allowed to add and subtract when they're different, only if you can make them the same. That's important. Okay, if you can't make them the same, then you can't do the problem. Okay, you can't add and subtract. Okay, so let's do a few more here. Let's do, let's see, 8 root 12 minus 3 root 27. Okay, All right, cool. So I see that 8 and that 12 is, if I divide it by 2, so again, I'm going to write these on top here. 2, 3, 5, and 7. Okay. 12 is 4 and 3. I'm just going to kind of go a little, well, here, 4 times 3, right? And then 4 is 2 times 2. Minus 3. And then 27 divided, well, I can't do divide by 2 because it's an odd number. So 27 divided by 3 is 9. Actually, let's do it up here. So it's 3 times 9, and then 9 breaks up to 3 and 3. Okay, so that's everything broken up. So we have a pair of 2's, and we have a pair of 3's here. So that comes out, that comes out. And so you have, when it comes out, you have 2 times 8 with a root 3, minus, and then take the 3 out, 3 times 3 with a root 3 left over. Okay, so this first one gives us 16 root 3, and this one gives us minus 9 root 3. Sweet! Same number of the radical. 16 minus 9 is 7. The answer is 7 root 3. Okay? Not bad, not bad. Okay, and again, if you can't combine them together, you know, if it's not the same number of the radical, then you can't combine them together. Okay? So let's try another one here. How about let's see, 3 square root of 20 minus square root of 12 minus 2 square root of 24 and let's say plus let's see, square root of 18. Let's see, 2 square root of 18. Okay, so we got kind of a variety of stuff here. This is good. So I'm going to start splitting up. What am I going to write on top here? I'm going to write on top here 2, 3, 5, and 7. Okay, so I'm going to kind of do a little faster here. 20 breaks down to 2 times 2 times 5. 12 breaks down to 2 times 2 times 3. 24 breaks down to 2, oops, I forgot the 2 here, 2 times 2 times 2 times 3. And 18 breaks down to 2 times 3 times 3. Okay? Completely broken down. So we're going to pull that out, we're going to pull that out, we're going to pull that out, and we're going to pull that out. And let's see what we got left over. So I pull the 2 out, I get, let's show my work here, 2 times 3, root 5, minus the 2 just comes out, root 3, minus I pull the 2 out, 2 times 2, root 3, and I pull the 3 out, so plus 2 times 3, root 2. Okay, so I have 6 root 5 minus 2 root 3 minus 4 root 3 plus 6 root 2. Okay, so the only thing, math fans, that I can combine together is this guy right here because we've got the root 3's. So that 6 root 5 is all by itself, so 6 root 5. And then negative 2 minus 4, right? This minus this is negative 6 root 3, and then plus 6 root 2. And we're done with the problem. Okay? Not bad. Not bad. You're going to get the same thing with cube roots, right? If I have, let's see, well, let's just do a really basic one. But if I have 2 times the cube root of, let's do 16, and minus 5 times the cube root of 2. Okay, so let's do this one first. That cube root of 16 is 2 times 2 times 2 times 2. That's broken up completely. Okay, and then I can't do anything with this 5 cube root of 2. So I'm going to pull out a perfect cube here. That comes out. So I wind up getting 2, and then the 2 that I just pulled out, cube root of 2 minus 5, cube root of 2. So it gives me 4 cube root of 2 minus 5 cube root of 2. So 4 minus 5, so same thing, same radical, same, it's the cube root. So 4 minus 5 is negative 1. So my answer is negative 1 times the cube root of 2. Or you could just say either one. You don't have to even have that negative 1. You could say negative the cube root of 2. But I don't care. Either one's fine. Okay? Okay, the only last thing I need to show you guys is when you have a variable. And again, that's not really a big deal. So if I have, let's say, 7 cube root of x, or sorry, 7 square root of x, minus 5 square root of x. Let's just start with the basic one. So it's the same thing as before. It's if I have 7 cube roots of x and I'm taking away 5 cube roots of x, I have 2 cube root of x. Or did I say cube root? That's fine. Doesn't matter. Okay? Cube root of x. There we go. And that's your answer. So it's like really easy. So here, let me just do a quick one. I kind of messed that one up a little bit there. 10 times the 5th root of x plus 4 times the 5th root of x. Okay, same thing. So 10 of those and 4 of those is 14 times the 5th root of x. That's your answer. Okay, if you have a number and a variable together, again, we've done this already, numbers and variables. But if I have 7 times the square root of 8x plus 4 times the square root of 2x. Okay, so I'm going to simplify that 8. I got to pull that 8 out, right? So I'm going to write it out. 7 times the square root, 2 times 2 times 2x plus 4 times the square root of 2x. So I can pull that out, and that gives me 2 times 7, and you got 2x left over, plus 4, this is the square root, so 4 square root of 2x. Okay, so that gives you 14 times the square root of 2x plus 4 times the square root of 2x, and that equals 14 of those plus 4 of those is 18 square root of 2x. And that's your answer. Okay? So that's it, my friends. That's adding and subtracting. They have to be the same. Can't add them together if they're not the same. Can't subtract them if they're not the same. They have to be the same in order to combine those guys together. All right? That's it, math fans. You have an outstanding day. Adios. Goodbye.